Hi! In my video about 3D printed gears, I showed you that the drive units of my remote controlled tank aren't up to the task. So in today's video I would like to show you the replacements. These feature higher powered motors with more torque, steel bevel gears, and all in a housing that's hopefully stiff enough to hold all the forces and to keep the gears together. I'd like to assemble the right hand side unit today, and hopefully you'll pick up some tips and some ideas along the way on how you can build your own. The first thing that I want to do is insert the bearings. Now, usually I would insert the bearings by pressing them in with my vise. But there is not enough access in here for my vise jaws to get in there. Another option is you could use one of these glue clamps. But these sometimes go out of parallel a little bit, and it's sometimes a little difficult to get them in position properly. So what I'm going to do today is use a nut and a bolt with two washers. So I'm going to take this bearing, I'm going to put a washer on the outside, I'm going to put a washer on the inside. Now this washer is fairly large because I want it as much as possible to press on the outer race of the bearing and not on the inner race. And then I put the nut on there. And then I grab two wrenches. And then as I tighten this nut onto this bolt, the bearing will slowly go into place. And as I get to the end here, when I notice a sharp increase in the resistance, that's when I know that I've hit home. Right around there. So I just need to loosen it up about a half turn, and then it's sufficiently loose that it just comes out easily. So that's on the right hand side. And then on the other side I have a smaller bearing, and so I'll need a smaller set of nuts, bolts and washers to do it on the other side. The next thing I want to do is insert the motor, and this is quite tricky because the hole that I have here is quite tight. And so to give myself some more grip, I've put my gloves on. The first thing I'm going to do is remove this magnetic shielding from the motor. And this is so that I can grip the motor and not this magnetic shield. Then I'm going to put the motor in. And this isn't too difficult yet. And what I have to do now is put the screw in, and then I will gently twist the motor in the hole until one of the screws pops in. So it's now in the hole properly. And then we rotate the motor, and there it clicks into place. So now if I grab a wrench, I should be able to drive this home. So you can see the screw going in, and then that will eventually tighten it up. Now I could have made some access holes on this end here so that I can stick my Allen wrench through, but I thought that that might weaken the stiffness too much on this end, so that's why I decided not to do that. It does mean that tightening these screws down is a whole lot more annoying, and at the final end you have to really do it a sixth of a turn at a time, like this. So I have to go like that, reset, and then. So that's kind of tedious and annoying, but in a couple of minutes you do get there. The next job is to install the pinion, and to do that I first want to rotate the shaft around a little bit, and I'll use my pliers for that, because I want to of course have the set screw impacting the flat bit on the D shaft, so I first have to make sure that that points up, and once that's the case I can just slide the pinion over the shaft, and tighten down the set screw. And speaking of set screws, the gears that I get from China are blanks like these, so they don't have any feature to them that allows you to fix them to a shaft. So I've drilled and tapped M6 holes in there for set screws, and because these are solid steel gears, that works just fine. You can tighten those up fairly hard and you can get a lot of holding force out of that, a lot more than you can get with a 3D printed gear, simply because the steel is stronger than the plastic of a 3D printed gear. The final step is to insert the output shaft. So we're going to do that from the right here. And then as we go, we'll add all of the components that have to go on it in the right order. So you can see the correct order here on the left. First, the locking collar, then the main gear, and then finally behind the gear we need a little spacer. And then you can use an Allen wrench. You can poke that through the rear bearing so you can guide the spacer to where it needs to go. So the final thing I need to do now is get the locking ring over the shaft collar. Push it home a little further. And then I need to get these two aligned so that I can drop a pin through them. So what I can do is I can block the rotation of the collar while I'm trying to rotate the shaft. You can do that in both directions. And then hopefully at some point I will get the alignment correct. And there we go. And then I tighten the set screws on the gear. You can tighten the set screws on the gear quite substantially to give them the maximum holding force. It takes a lot of torque to strip out threads that you've tapped into solid steel. And there we have it, 2 drive units. So in the next episode I'm going to be building these into my remote control tank. I'll also be fixing up some of the electronics, give a little bit better technique of mounting everything inside. And just to get a complete picture of where this is going, I have a hole here and a spline shaft. So I can put this sprocket over there. And this kind of works like a T34. So the guide horns will fall into these pockets and that will push the track along. So I hope to see you then. Thanks again for watching. I'll see you again.